Most enterprises blame Copilot agent failures on early platform chaos. That story is comforting. It's also wrong. Agents fail because teams deploy conversation where they need control, then act surprised when outcomes aren't repeatable, auditable, or safe to scale. In the next hour, this goes from provocation to a Monday morning mandate. How to design agents like governed systems, not chat experiences. If you're building Copilot Studio agents inside a real tenant, identity, data, power platform, service, now subscribe. This channel is where the architecture gets enforced, before the sprawl becomes policy. The foundational misunderstanding in chat is not a sister. The foundational misunderstanding is simple. People treat chat like a system interface. Chat is not a system, it's a user experience layer. That distinction matters because enterprises don't run on friendly conversations. They run on inputs, state, outputs, and accountability. They run on repeatability. They run on the ability to prove what happened, why it happened, and who authorized it. A chat box gives you none of that by default. It gives you a vibe. Here's what chat does architecturally. It hides the boundaries. It collapses intent capture, decisioning, and execution into one continuous stream of text. And the moment you do that, you lose the ability to say, this is the point where the system decided, and this is the point where the system acted. In other words, you can't draw the audit line. Enterprise systems run on contracts. A request has a defined shape. Inputs get validated. State changes happen inside boundaries. Outputs have lineage. Failures stop, retry, or escalate with evidence. Chat doesn't do contracts by default. It does interpretation, sometimes useful, sometimes wrong, always harder to reproduce than a workflow. That's not a moral critique of AI. That's a system behavior description. The enterprise problem starts when teams mistake fluent language for bounded decision logic. They assume that if the agent can talk through a process, it can run the process. But language is not a control plane. Language is not policy enforcement. Language is not a transaction boundary. Language is just output. The cost of this shows up as friendly ambiguity. Everyone loves friendly ambiguity in demos because it feels flexible. In production, it creates 3 predictable outcomes: inconsistent actions, untraceable rationale, and audit discomfort. Inconsistent actions happen because the agent doesn't have a deterministic decision boundary. The same request from 2 users becomes 2 different interpretations. The same request from the same user on Tuesday becomes a slightly different path on Wednesday because context changed, the model changed, a connector throttled, or a knowledge source returned different chunks. And now your process is a probability distribution. Untraceable rationale happens because chat encourages narrative. The agent explains, it justifies, it sounds reasonable, but the organization can't verify which data it used, which policy it applied, which tool contract it invoked, and what preconditions were true at the moment of action. You get a story, you don't get evidence. Audit discomfort is the inevitable end state. Not because auditors hate AI. Auditors hate ambiguity, outcomes you can't reconstruct, and decisions you can't attribute. That's not a control story, that's an incident review waiting to happen. So what is the real job of an enterprise agent? It is not answer questions. That's a small, safe subset. The real job is delegated decisioning plus delegated execution under constraints. Delegated decisioning means the agent can choose a path. Which workflow to trigger, which record to retrieve, which policy applies, which exception requires escalation. Delegated execution means the agent can cause state change, create a ticket, update a record, submit an approval, notify a user, write to a system of record. And the phrase under constraints is the entire point. Constraints are what turn AI from a probabilistic assistant into an operational component. Most organizations skip constraints because constraints don't demo well. Constraints look like friction. Constraints look like governance. Constraints look like someone saying no. But constraints are the design, they are the architecture. When you deploy chat-first agents, you're delegating without defining boundaries. You are handing a conversational interface, a set of tools, and saying, be smart. Then you're surprised that it behaves like a conversational interface with tools. And once the agent can act, the consequences stop being theoretical. The failure mode isn't it answered wrong. The failure mode is it updated the wrong thing. It approved the wrong thing. It exposed the wrong thing. Or the quietest failure of all. People stop trusting it and routed around it. That's why more prompts doesn't fix this. Prompts can shape tone. Prompts can reduce some ambiguity. Prompts can nudge behavior. But prompts cannot manufacture a control plane that doesn't exist. They can't create missing contracts. They can't make identity decisions explicit. They can't enforce tool allow lists with preconditions and refusal rules. They can't produce an audit trail if the system of record was never part of the design. So the first mandate is structural. Stop asking chat to behave like a system. If you want enterprise outcomes, you need enterprise mechanics. And that's where this gets uncomfortable, because it means the agent isn't the product. The product is the architecture around it. Truth 1. Most agents fail because they're too conversational. Here's the first truth that gets people defensive. Most Copilot agents fail because they are too conversational. Not because conversation is bad, because conversation becomes the center of gravity and everything else becomes optional. identity discipline, input validation, transaction boundaries, evidence. The chat-first pattern looks harmless at the start. A team opens Copilot Studio, writes friendly instructions, connects knowledge, adds tools, and ships. The demo works. Then it hits the tenant. Partial permissions, messy data, throttling, edge cases, and a decade of just this once exceptions. In a chat-first agent, intent capture is vague by design. The user asks, "Can you help me with onboarding?" And the agent has to decide what help means. Answer questions, create accounts, request equipment, assign training, open tickets, notify managers. The user didn't specify, and the agent doesn't have a contract that forces specificity, so it improvises. And improvisation is fine for discovery. It's lethal for execution. The next failure is tool choice. In a conversational pattern, tool invocation becomes a kind of live improvisational routing. The model selects what it thinks is the right connector, the right action, the right flow, based on whatever context it has in that moment. If two tools overlap, it guesses. If a tool fails, it tries something adjacent. If the knowledge source returns an ambiguous chunk, it fills the gap with language. This is where more prompts becomes the wrong fix. Teams respond to bad behavior by adding more instructions. Always do X, never do Y. Ask clarifying questions. Confirm before you update. They stack paragraphs of policy into an 8,000-character text box and call it governance. But prompts don't create determinism. Prompts create persuasion. They're an influence layer on a distributed decision engine. When the system has conflicting signals, user language, retrieved context, tool schemas, permission failures, connector timeouts, the prompt isn't a compiler. It's a suggestion, and enterprises don't run on suggestions. This is also why more language doesn't equal more intelligence. Verbosity is a masking layer. A chat-first agent can produce a long, confident explanation while the underlying decision boundary remains undefined. The output sounds like control. The system behavior is still probabilistic. Stakeholders notice this in one specific way. They can't get the same result twice. Different wording produces different routing. Different day produces different answers. The same action request assumes different preconditions. Then IT gets asked, what happens when we roll this out to 30,000 people? A conversational agent can't answer that reliably. And when an agent can't predict its own action path, you're not deploying automation. You're deploying conditional chaos. Now, there is a place where chat works extremely well. Chat is great at discovery, triage, clarification, summarization. Help me understand what's going on. Show me the options. Explain the policy. Which team owns this? That's where probabilistic behavior is acceptable because the output is advisory, not state-changing. Chat is also great at absorbing messy inputs from humans and turning them into structured parameters. That's valuable. But it's a front end, not the engine. The mistake is asking chat to be the engine. The moment you let conversation carry the workflow, you've made the workflow dependent on language variance. And language variance is infinite. Users will ask the same thing 10 different ways. They will omit details. They will paste screenshots. They will drop half a ticket history into the chat and expect the agent to just know. So the right design move is not make the agent more conversational. It's the opposite. Make the agent less conversational where it matters. Shrink the conversation surface to parameter collection and confirmation. Force decision boundaries into explicit routing. Push execution into deterministic systems, flows, APIs, orchestration that you can test, version, and audit. Which raises the obvious question. If chat can't be the center of gravity, what can? A control surface, delegation with contracts, an agent designed like an enterprise system, not a personality. Truth 2, an agent is a delegated control surface. Truth number 2 is the one that breaks most org charts. An agent isn't an AI employee, it's a delegated control surface. And the difference matters because employees come with training, supervision, professional judgment, and critically, personal accountability. Agents come with none of that. They come with permissions, tools, data pathways, and a model that will happily produce a plausible plan even when the environment is lying to it. So when someone says, we're giving the HR agent access to onboarding systems, what they're really saying is, we're exposing a set of execution pathways to a probabilistic decision engine. That's not inspirational, that's a risk statement. The capability of an agent equals the sum of what you exposed, not what you wrote in instructions, not what the demo showed. Exposed pathways, identity context, connector permissions, action schemas, knowledge sources, and whatever the platform can reach at runtime. That's the real surface area. And in enterprise systems, surface area is destiny, because agents don't amplify your best process. They amplify your weakest governance path. If your tenant already has temporary exceptions over permissioned service accounts, stale app registrations, connectors nobody owns, SharePoint sites that grew like mold, an agent doesn't fix that. It automates it at speed with a friendly explanation attached. This is why the AI employee metaphor is so dangerous. It tricks leadership into thinking the hard part is adoption and change management. But architecturally, the hard part is delegation mechanics. Who authorizes, who executes, and who owns the outcome when things go wrong. Start with authorization. In a real system, an action doesn't happen because someone asked nicely. It happens because an identity with the right entitlements invoked a defined operation under policy. With agents, people blur that line. They assume the user's request is the authorization. It isn't. It's input. Authorization is the control plane decision. Should this user, in this context, be allowed to cause this state change using this tool right now? Then execution. Execution is where the damage happens because execution changes state outside the chat. Create, update, delete, approve, notify, escalate. If you let a model choose those operations freely, you've moved from assistant to unbounded operator. And that's fine in consumer software. Enterprises don't get to do fine. And then ownership. When an agent updates a record incorrectly, who owns that incident? The maker, the system owner, the identity team, the business sponsor. Everyone will point at everyone else unless you force it into the design. That's why agents need an explicit responsibility model, not a vague product owner label in a spreadsheet. Here's the uncomfortable truth. Delegated execution without explicit ownership becomes political debt. Fast. Now connect this back to what people actually build. A Copilot agent is a UI that fronts a bundle of integrations. Each integration has a failure mode. Permission denied, throttling, schema change, timeout, bad data, partial success. When those happen, the model will try to be helpful. It will root around. It will attempt an alternative. It will summarize a guess. And if you didn't design a refusal rule or an escalation path, it will keep going. That means your agent is not helping employees. It is making runtime decisions in a distributed environment you barely control. So the mandate is not make the agent smarter. The mandate is make delegation explicit. Define the identity model. Run as user, run as service, or hybrid with consequences documented. Define the tool allow list. Which actions exist, what inputs they accept, what outputs they return, and what errors look like. Define the decision boundaries, what the agent may infer, what it must verify, and when it must stop. And define the audit surface. What gets written to the system of records so the business can reconstruct why something happened. That's the difference between an agent as a novelty and an agent as an enterprise-controlled surface. And once you accept that framing, enthusiasm becomes irrelevant. Architecture becomes the product. Which is exactly where this goes next. Deterministic ROI only shows up when the design itself is deterministic. The architectural mandate, deterministic ROI, requires deterministic design. So here's the mandate, stated plainly. The moment an agent can take action, you stop building an agent. You start building a system. And systems only produce ROI when they behave predictably under real conditions. Partial data, partial permissions, outages, policy changes, and users who never read your documentation. That distinction matters because most ROI conversations about agents are really demo conversations. They measure how impressed someone felt, how quickly a pilot team shipped, how many questions the agent answered without embarrassing itself in a meeting. That's not ROI, that's novelty with a budget. Deterministic ROI is different. Deterministic ROI means you can name the outcome, measure the delta, and trust it will repeat tomorrow at 10x scale without turning into an incident backlog. And that only happens when the design is deterministic where it needs to be. Enterprises tolerate probabilistic behavior in one place, interpretation. They tolerate variance in how a user asks a question, how an agent summarizes information, how it suggests next steps. That's the reasoning layer, and it's useful. They do not tolerate probabilistic behavior in execution, not in approvals, not in record updates, not in entitlement changes, not in ticket routing, not in anything that moves state in a system of record. So the architectural mandate is a separation of concerns. Let the model do what models are good at: language normalization, intent extraction, ambiguity detection, summarization, and classification. Then hand execution to what enterprises already trust: deterministic workflows, explicit APIs, validated inputs, and governed identities. The core line is still the simplest one. Chat is for discovery, agents are for execution. Confuse the two and you automate ambiguity. And yes, some people will argue, but the model can do tool calling, it can choose actions. And of course it can. That's not the question. The question is whether you can prove ahead of time what it will do with a given intent. If you can't predict the action path, you can't govern it. If you can't govern it, you can't scale it. If you can't scale it, your ROI is a one-time demo artifact. Determinism isn't about removing AI. It's about placing AI inside a design that can survive entropy. Because entropy is the default state of every tenant. Connectors drift, permissions drift, knowledge sources drift. People leave. Temporary exceptions become permanent, platforms update, models update. Suddenly the agent behaves differently and no one can explain why. A deterministic design assumes drift, it constrains it, and it creates a stable envelope where change can happen without turning behavior into roulette. So what does that actually look like in practice? It looks like contracts, not instructions. Contracts. A contract says, for this intent, these are the required inputs, these are the allowable tools, these are the preconditions, and these are the outcomes we will write back to the system of record. If any of those aren't true, the agent refuses, escalates, or routes to a human. No improvisation, no best effort updates to production systems. This is also where people misunderstand deterministic as rigid. It isn't. You can be flexible in how users express intent and strict in how the system executes. That's exactly how mature enterprise software already works. Humans type messy things into forms all day. The system doesn't take the mess literally. It validates, normalizes, and enforces policy. Agents need the same shape. So when someone asks for proven ROI, the real answer isn't build a better prompt. The real answer is design an agent that produces repeatable outcomes. Repeatable means the same intent and the same state lead to the same execution path. Measurable means you can track throughput, cycle time, escalation rate, and error rates without arguing about definitions. Stable means you can operate it, version it, test it, roll it back, and audit it. That's deterministic ROI. And it's the only ROI that survives beyond the pilot phase. Everything else is the familiar pattern. Initial excitement, then drift, then exceptions, then manual overrides, then quiet abandonment. So the mandate is architectural honesty. Decide where you accept probability and where you demand certainty. And to make this concrete, the next piece is the decision model that replaces chat-first agents entirely. Because once you see it, you stop designing conversations. You start designing systems that happen to speak. The decision model, event, reasoning, orchestration, execution, record. Here's the replacement model. Not a better chat, a decision system that happens to speak. Event, reasoning, orchestration, execution, record, 5 stages, clear boundaries, clear ownership, clear evidence. Start with the event because enterprises love to pretend an agent just helps people. It doesn't. An enterprise agent should start because something explicit happened, a user request in Teams, a form submission, a ServiceNow ticket moved to a new state, a high-risk sign-in event, a scheduled daily run. You don't let the agent wake up based on vibes. An event is the trigger contract. It answers what starts this, who started it, and what context is guaranteed at the start. That matters because most agent drift starts at the beginning. If the start condition is loose, everything downstream becomes interpretive. Loose triggers create loose outcomes. Deterministic systems don't start that way. Next, reasoning. This is where the model earns its keep, but only inside a bounded context. Reasoning means interpret messy human language, detect ambiguity, extract parameters, classify intent, and decide what must be verified before anything happens. It's also where the agent can say, I can do that, but I need these 3 inputs, or I can't do that without approval. Bounded context means the agent is not allowed to treat the entire tenant as its memory. It gets a defined set of knowledge sources, a defined set of operational data, and a defined set of assumptions it may make. Everything else is either verification or refusal. This is where a lot of teams get lazy and call retrieval reasoning. Retrieval is just scavenging. Reasoning is deciding what to do with what you found and, more importantly, what you're not allowed to do without stronger evidence. Then orchestration. Orchestration is policy, not creativity. Orchestration decides which tool is allowed to run for this intent under these conditions with these inputs. It is the layer that converts the user asked a thing into we are invoking exactly this contract. If 2 tools overlap, orchestration doesn't guess. It routes. This is where the allow list lives. This is where preconditions live. This is where refusal rules live. If the user wants an action that isn't in the contracts, the agent doesn't improvise. It stops. It escalates. It returns a structured can't comply with the reason and the handoff path. And yes, Copilot Studio can do orchestration in different ways. Topics, generative orchestration, tool definitions, agent flows. The mechanism isn't the point. The point is that orchestration behaves like an authorization compiler. It turns intent into permitted operations, or it rejects it. After orchestration comes execution, and execution should be boring. Execution is where deterministic systems do deterministic work. Power automate, logic apps, APIs with typed schemas, workflows with idempotency, so run it again doesn't duplicate side effects. Retries with timeouts, known failure states. The stuff that incident reviews actually understand. The agent should not execute by narrating and then doing ad hoc tool calls until it feels done. That's conditional chaos disguised as helpfulness. Instead, execution runs through components you can version, test, and observe. You can run them in isolation. You can gate releases. You can roll back. You can prove exactly what happened when an action mutated state. And finally, record. This is the stage most teams skip, and it's why trust evaporates. A system that can't write its outcomes and rationale to a system of record isn't an enterprise system. It's a suggestion engine with side effects. Record means capture the event, the intent, the key inputs, the policy decision, the tools invoked, the outcome, and the handoff if it escalated. ServiceNow is a common center of gravity here, not because it's magic, but because it already represents state ownership and auditability for work. It's where work becomes accountable. The record is also how you measure ROI without lying to yourself. Not users liked it. Actual deltas, cycle time, escalation reduction, rework rate, exception volume, manual intervention. So this model does one crucial thing. It moves the agent from being a conversational blob to being a controlled pipeline. Humans can still type messy requests. The model can still reason. But action happens only through contracts, and evidence lands in systems that governance already understands. Now, the uncomfortable part. Once you build this way, you'll notice how many popular agent designs are the exact opposite, and they fail in the same three ways every time. The anti-patterns, 3 ways enterprises build conditional chaos. Now you can spot the anti-patterns instantly because they all violate the same law. They collapse decisioning and execution back into chat, then pretend governance will catch up later. There are 3 versions of this. Enterprises rotate through them like it's a maturity model. It isn't. It's just 3 different ways to automate ambiguity. Anti-pattern 1, decide while you talk. This is the agent that narrates a plan and commits actions in the same breath. The user asks, "Can you offboard this contractor?" The agent starts explaining the steps. But while it's explaining, it's also calling tools. Disabling the account, revoking sessions, removing licenses, closing access groups, updating a ticket. It feels efficient because it keeps the conversation moving. But architecturally, it's catastrophic. Because the system has no hard boundary between thinking and doing. The plan becomes execution. And once the agent can do partial work, you get the worst possible failure mode, half-completed state change with a polite summary at the end. In incident terms, this is how you end up with account disabled but mailbox still accessible, ticket updated but approvals missing, access removed in one system but not the other. Then the user asks, wait, did it actually do it? And no one has a clean answer because the conversation transcript is not an audit log. The enterprise requires a commit point, a confirmation, a transaction boundary. If the agent can't separate "I understand what you want" from "I am now changing state," you don't have automation. You have a probabilistic operator. Anti-pattern 2, retrieval equals reasoning. This is the agent that gets praised because it knows a lot. It has SharePoint, it has PDFs, it has a knowledge base, it can search, it can quote internal docs, and the team assumes that because it can retrieve context, it can make operational decisions. But retrieval is not reasoning. Retrieval is just context scavenging. In other words, the agent can find text that looks relevant, but it still has to decide what that text means, whether it applies, whether it's current, whether the user is allowed to act on it, and whether the text implies an executable workflow or just a guideline. And here's the weird part. Retrieval makes agents look more confident while being less safe, because now the agent can anchor a wrong decision to a real paragraph. It can cite a policy snippet that is outdated, incomplete, or scoped to a different business unit. The output feels grounded. The decision is still unbounded. This is where audit risk quietly grows. If the organization can't attribute which source, which version, which section, and which rule actually governed the action, we retrieved something becomes a liability, not a control. Retrieval supports reasoning. It does not replace it. Anti-pattern 3, prompt branching logic that nobody can explain after the third exception. This is the agent that starts as a clean pilot, a few intents, a few flows, a few prompts. Then reality shows up. Someone needs an exception. Then another, then a special case for one region, then a temporary bypass because a connector is flaky, then a workaround because the knowledge source isn't updated yet, so the team keeps adding conditional text. More instructions, more if the user says X, do Y, unless Z. The logic lives in prompts, topic nodes, and scattered tool descriptions. It's not versioned like a workflow. It's not tested like software. It's not even readable as a policy document. Over time, the agent becomes an entropy museum, every workaround preserved forever. And the symptom pattern is consistent. First, manual overrides. People rerun the workflow just to be safe. Second, inconsistent approvals. The same request goes down different paths because the branching rules depend on phrasing and context chunks. Third, silent failure modes. The agent times out, falls back, or partially completes actions while telling the user it handled it. This is how trust dies, not loudly, quietly. Users stop escalating issues because they stop expecting the agent to behave. They root around it, they go back to email, Teams messages, and tribal knowledge. Leadership still thinks there's an agent program. In reality, there's an abandoned chat surface connected to production systems. So if you want a quick diagnostic, when an agent fails, ask where the decision boundary lives. If it lives in conversation, you build conditional chaos. If it lives in contracts, orchestration, and a system of record, you build something that can survive scale. Now it's time to show what contracts first looks like when a regulated enterprise does it on purpose. The success case, regulated enterprise that started with contracts. A regulated enterprise doesn't get agents right because they're smarter. They get it right because the environment punishes improvisation. If you're in financial services, pharma, aerospace, or regulated manufacturing, you don't get to hide behind "the model did something weird." You either produce evidence or you produce risk. So the teams that succeed don't start by asking, what can Copilot do? They start by asking, what are we allowed to delegate, under what constraints, with what proof? That distinction matters because it flips the build order. The success pattern looks boring on purpose. It starts with contracts and identity. Only later does it add conversation. In one program like this, the initial scope wasn't automate everything. It was one value stream that already had a system of record and a known escalation path. Think service requests, approvals, or controlled changes. The agent didn't own the process. It owned a narrow slice: intake normalization, parameter validation, routing, and execution of a fixed set of actions. And the first architectural decision was the one most pilots ignore: who does this run as? They made the identity model explicit upfront. User-delegated actions stayed user-delegated. Service-executed actions ran under dedicated identities with least privilege. No shared maker credentials. No temporary admin access because it was faster. Every permission was treated as a contract, not a convenience. Because in regulated environments, identity drift becomes audit drift fast. The second decision was context architecture. They didn't attach SharePoint and pray. They treated knowledge like a product with owners, lifecycle, and versioning. Policies had effective dates. Operating procedures had controlled revisions. If the agent referenced content, it had to be attributable to a source that governance already recognized as authoritative. That one move eliminated a whole class of failures. The agent quoting plausible but obsolete guidance. Then came tools. And here's the subtle win. They separated reasoning from execution by design. The model did the reasoning in Copilot. It extracted intent, detected ambiguity, and assembled a structured request. But the actual work, creating records, updating status, routing approvals, ran through deterministic workflows. Power Platform handled the execution layer because it already supports the things enterprises need to stay sane: typed inputs, idempotency patterns, retries, timeouts, and predictable failure states. Copilot didn't wing it with a string of tool calls until it felt finished. It invoked defined contracts. And for the system of record, they didn't try to make Copilot the ledger. They used ServiceNow or an equivalent as the state authority. Every agent-initiated action wrote an entry: what was requested, what was executed, which workflow ran, what the outcome was, and what escalation occurred if something didn't meet preconditions. So when someone asked, why did this ticket get approved? The answer wasn't a chat transcript and a shrug. It was a reconstructible chain. Now, the measured outcomes in these environments tend to look unexciting in a keynote and extremely valuable in operations. Escalation loops dropped because the agent didn't bounce between teams based on vibe. It routed based on contract. Approvals became predictable because the agent didn't invent preconditions. It validated them. And audits stopped being theatrical because evidence existed by default, not as a retroactive scramble. The most important outcome wasn't time saved, it was trust preserved. Because once users see an agent behave consistently, same intent, same path, they stop treating it like a novelty. They start treating it like a service. And services can be operated, monitored, improved, versioned, and scaled. Here's what most people miss. This wasn't a Copilot Studio success story. It was an architecture success story implemented with Copilot Studio. Same platform, same connectors, same models, different sequence, different constraints, different definition of done. And that's why regulated enterprises often look like they're moving slower in month 1, and then suddenly they're the only ones with agents that survive month 6. Because they built the boring parts first: contracts, identity boundaries, and systems of record. Conversation came last, which is exactly why the opposite build order failed so reliably, because when you start with chat, you end with a trust problem you can't patch later. The failure case: the chat-first agent that lost trust quietly. Now for the contrast case: same platform, same shiny features, completely different outcome. This one usually starts with a sentence like, "We just need an agent that helps people." No outcome definition, no bounded scope, no contracts, just a chat surface and optimism. So a small team spins up an agent in Copilot Studio. They give it broad instructions: be helpful, be concise, follow policy. They attach a pile of SharePoint sites because more knowledge is better. They connect a few tools because the demo needs motion: create a ticket, update a record, maybe send an email. And because they want adoption, they deploy it in teams where everyone already lives. The first week looks great. People ask simple questions. The agent answers. It finds the right doc more often than not. It creates a few tickets. Leadership gets a screenshot. The project gets declared a win. Then the environment shows up. A user asks the same question in a slightly different way. The agent routes to a different topic. Or it doesn't route at all and falls back to a generative answer that sounds plausible. Someone pastes a ticket thread into the chat and the agent quietly times out. Someone else asks for an action that should be allowed, but the connector runs under a different identity model than anyone documented. So it fails, and the agent masks it with language. This is where trust starts eroding. Not from one catastrophic incident, but from tiny inconsistencies that accumulated. The most damaging moments are the ones that look like success. The agent says done, but the record didn't change. Or it created the record but missed a required field, so downstream automation didn't run. Or it updated the wrong object because two systems have similar names and the tool schema wasn't explicit enough. In a chat interface, that's just one more message. In operations, it's rework. So humans compensate. They start double-checking everything the agent does. They rerun steps manually. They keep the agent open as a suggestion box, but they stop letting it touch systems. The intervention rate climbs, but nobody measures it. The agent's usage metric looks fine for a while because people still chat with it. They just don't trust it. Then comes the second phase, drift. Someone updates the prompt to fix a behavior. Another person adds a new topic trigger to catch an edge case. A third adds another knowledge source because it didn't know this one thing. None of this is wrong individually. The failure is that these changes aren't treated like production releases. They aren't gated by tests. They aren't tied back to explicit contracts. They just happen. Over a couple months, the agent becomes harder to predict even for its builders. Now add normal platform reality, connector throttling, model updates, content indexing changes, permission adjustments, conditional access shifts. Nothing dramatic, just the slow churn of a real tenant. The agent starts behaving differently on Mondays than it did on Fridays, and the team can't tell if that's AI being AI or a dependency drifting underneath it. Users don't file bug reports for that, they root around it. And this is the quiet death that most agent programs misread. The agent doesn't fail loudly, it becomes optional. People stop recommending it to new hires. Managers stop pointing teams to it. The team's channel gets less traffic. The agent still exists, so the organization tells itself it's early days. What actually happened is simpler. The system never earned the right to be trusted because its design never made outcomes repeatable. And if you ask the team afterward what went wrong, you'll hear the comforting story again. The platform is immature, or users weren't trained, or we need better prompts. But the pattern is architectural. They deployed conversation where they needed a control plane. They let intent stay vague. They let tool selection be improvisational. They treated knowledge sprawl as context. They skipped a system of record for decisions and outcomes. They built a chat-shaped workflow, then acted surprised when it behaved like one. So the contrast case isn't a warning about Copilot Studio. It's a warning about build order. Chat first feels fast because it ships a surface. Architecture first feels slower because it ships constraints. But only one of those survives contact with 30,000 users, 3 business units, and a security team that eventually notices you automated the weakest path in the tenant. And that's the lesson. Same tools, different architecture, different reality. Now the question becomes actionable. If Monday morning is real, where does an enterprise start? Before the next helpful agent becomes another quietly abandoned Teams tab. Monday Mandate Part 1, start with outcomes, not use cases. So Monday morning, if you want this to stop being theater, you start with outcomes, not use cases, not ideas, not what Copilot Studio can do. Outcomes. Because use cases are how organizations hide from accountability. A use case can be anything. It can be a demo, it can be a chatbot, it can be a SharePoint search box with better manners, and it can still produce exactly 0 operational improvement while everyone nods like progress happened. An outcome is different. An outcome forces a before and after. Cycle time moves. Escalation rate drops. Throughput increases. Rework decreases. Compliance evidence becomes easier to produce. Those are outcomes. They're measurable deltas that survive outside the agent team's slide deck. And the first thing leadership has to accept is this. If the outcome can't be measured, the agent isn't a product. It's a distraction. So define the outcome in the language the business already understands. For service and operations, mean time to resolution, first contact resolution, deflection rate with strict definitions, ticket reopen rate, approval time, exception volume. For sales, qualified opportunities, time to quote, proposal cycle time, RFP throughput. For HR, onboarding completion time, case backlog, handoff count, error rate in payroll, or benefits changes. Not vanity metrics like number of conversations, and not sentiment metrics like users said it was helpful, unless helpful is tied to a measured operational delta. Next, map the value stream, not the tool chain, the value stream. Where does a decision actually happen? Where does state actually change? Where does risk concentrate? Where do humans get pulled into loops because the system doesn't know what to do? This is where most agent programs get exposed. They pick the most visible pain point, not the most architecturally leverageable one. They automate questions because questions are easy. They avoid decisions because decisions create accountability. But ROI lives in decisions, specifically repeatable decisions with bounded variation. So you're looking for work that has 3 properties. First, repeatable intent. The request shows up in recognizable forms. Users ask it 100 times a week. It's not a one-off, solve my unique situation. It's a recurring demand signal. Second, bounded variation. There are edge cases, but the majority of requests fall into a small number of shapes. You can enumerate them. You can define what normal looks like. If every request is a snowflake, you don't have an agent opportunity. You have a consulting practice. Third, clear success criteria. You can say what done means without a meeting. The ticket is created with these fields, the approval is captured with these conditions, the record is updated, and the downstream automation ran. If success is subjective, you'll get subjective behavior. And subjective behavior is just another name for non-determinism. Now, once you've done that, you make a decision most teams avoid. Are you building a discovery experience or an execution experience? Discovery experience is optimized for understanding. They tolerate ambiguity. They help users find the right policy, the right owner, the right option, the right next step. They can live in chat with relatively low risk because the output is guidance. Execution experiences optimize for changing state. They require contracts, validation, and systems of record. They can still use chat as an interface, but the design is dominated by control. You don't mix these casually. If you do, you'll end up with an agent that helps users and occasionally performs actions, which is the worst possible positioning. The actions will be blamed when they're wrong, and the help will be ignored when it's right. So pick one per workflow. If the goal is execution, design the conversation to collect missing parameters and confirm intent. If the goal is discovery, explicitly refuse action and route to the appropriate system. Then you tie the outcome to an operating rhythm. Who owns the metric? Who reviews it weekly? Who decides what changes when the metric drifts? Because the agent will drift. The only question is whether drift becomes silent decay or managed iteration. This is why starting with outcomes is not bureaucratic. It's a control mechanism. It forces bounded scope. It forces measurement. It forces a system of record. It forces you to admit what you're delegating. And once outcomes are clear, the next part becomes non-negotiable. Boundaries, not best practices, not guidelines. Boundaries that define what the agent is allowed to do, what must be true before it does it, and exactly where it must stop. Monday Mandate Part 2. Intent contracts and decision boundaries. Once you've picked outcomes, you don't brainstorm prompts. You write contracts. Because the agent doesn't need permission to talk. It needs permission to act. An intent contract is the simplest artifact that forces that discipline. It's a plain language definition of one intent with a machine enforceable boundary behind it. It answers 5 questions: what the intent is, what the agent is allowed to do, what inputs are required, what systems it may touch, and what evidence it must produce. If that sounds like paperwork, good. Paperwork is what keeps state change from becoming folklore. Start with the intent itself. Name it like a system operation, not like a marketing feature. Create service request, reset MFA method, generate RFP draft, submit onboarding task, update incident status. If you can't name it crisply, it's not an intent, it's a category of vibes. Then define the allowed actions and write them like an allow list. Not help with onboarding, it does. Instead, create a ServiceNow request using catalog item X. Assign the request to group Y based on parameter Z. Send notification to manager via Teams using template T. The agent can only do what's enumerated. Everything else becomes refusal or escalation by design. This is where teams usually push back with, but users won't know what to ask for. That's fine. The model can translate messy language into a known intent, but translation is not authorization. The intent contract is authorization. Next, required inputs. Every action-capable intent has a minimum parameter set. If the parameters aren't present, the agent doesn't guess. It asks, and it asks narrowly. For example, which user? Which system, which effective date, which cost center, which approver. These aren't conversational flourishes. They are preconditions for safe execution. And the design move here is subtle. The agent should never request information it can deterministically retrieve. If Entra can provide the user's ID, the agent shouldn't ask the user to type it. If ServiceNow can return the ticket number from context, don't make the user restate it. The only questions the agent asks are the missing fields required to execute the contract. That keeps the conversation surface minimal and keeps the system boundary explicit. Now define preconditions. Preconditions are the must be true before tool invocation rules. This is where most agent programs silently fail because they treat policies as documentation instead of runtime gates. Preconditions are executable checks. User has role X. Ticket is in state Y. Record exists and is owned by this business unit. MFA reset allowed only if identity risk score is below threshold. Approval must be present before status change. In a deterministic design, preconditions run before any state change. If a precondition fails, the agent stops. It does not attempt a workaround. It does not pick an adjacent tool. It does not rewrite the policy in friendly language and proceed anyway. It escalates, which means you need refusal rules. Refusal rules aren't the agent says no sometimes. They are explicit boundaries. If the request touches privileged access, refuse and route to human approval. If the user lacks entitlement, refuse and provide the self-service path. If the context is ambiguous, refuse and ask for clarification. If the system of record is unavailable, refuse and create a fallback ticket. Refusal is a feature. It's the control plane proving it exists. Then comes separation of concerns because contracts only work when the architecture respects them. Intent capture lives in the conversation layer. Decisioning lives in the orchestration layer. Execution lives in deterministic tools. Recording lives in the system of record. If you collapse those layers back into a chat transcript, you'll get the same failure again, just with nicer phrasing. So on Monday, you don't start by improving the agent. You start by writing 3 to 5 intent contracts for one outcome, and you enforce them with decision boundaries the model cannot talk its way around. And you'll notice something immediately. The agent becomes less magical and more useful because it becomes predictable. Now, contracts alone still don't save you, because contracts without identity discipline are just aspirational text. So the next question isn't what can the agent do? It's the one nobody wants to answer in a steering committee. Who does the agent run as? Identity as control plane. Who does the agent run as? If you want one question that exposes whether an agent program is real or just a pilot hobby, it's this. Who does the agent run as? Not who built it, not who owns the Teams channel, not who pays for the license. At runtime, what identity actually calls the tool, touches the data, and changes state. Because the agent doesn't act as a concept, it acts as a token. And tokens obey the rules of Entra, conditional access, connector auth, and whatever accidental privilege you left lying around in the tenant. There are two dominant execution models, and both come with consequences you don't get to negotiate. Model 1, user-delegated execution. That means the agent calls tools using the signed-in user's permissions. It can only retrieve what they can retrieve. It can only update what they can update. In enterprise terms, this is the least surprising model because it preserves the existing access graph. It also gives you the cleanest accountability story. The user asked, the user had access, the action happened. But the cost is operational fragility. User-delegated execution inherits every problem in human identity. MFA prompts, session expiry, conditional access changes, device compliance, role changes, and licensing mismatches. It also means two users can get two different outcomes from the same request because their entitlements differ. That's not AI inconsistency. That's identity truth. And when people complain that an agent is unreliable, half the time they're describing authorization variability. Model 2, service executed execution. That means the agent calls tools under a non-human identity, a service principal, managed identity, or a dedicated runner's account with fixed permissions. This is the model teams choose when they want consistent behavior across users or when the workflow must run without a specific person present. It is also the model that quietly creates the biggest blast radius in your environment, because now the agent has a stable, reusable identity with standing privilege. If you overscope it, you didn't just create an agent, you created an automation backdoor with a chat interface. And once that exists, the question shifts from can the user do this to can the agent do this, which is exactly the wrong direction for governance. So the rule is simple. Least privilege isn't a policy document. It's an architectural boundary enforced by identity design. Every tool you expose has to bind to an identity model intentionally. If it runs as the user, you accept variance and you design for it. If it runs as a service, you constrain permissions to the minimum contract set and you treat changes like code. Now layer Entra on top of this because Entra is not a branding exercise. It is the policy engine that decides whether your architecture exists at runtime. Conditional access policies will shape agent behavior in ways builders often don't predict. Step-up auth, sign-in risk, device posture, location constraints, session lifetime, token issuance controls. The agent doesn't get exceptions because the maker is excited. If your action path depends on a token that CA will sometimes deny, your agent is probabilistic before the model even speaks. And then there's the slow killer, identity drift. Over time, access reviews don't happen. People get added to groups temporarily. App registrations accumulate permissions because it unblocked a project. Owners leave, secrets expire, service accounts get reused. You don't notice because the system still mostly works. Then you add an agent and it starts traversing those pathways at scale. The agent doesn't introduce new entropy. It operationalizes the entropy you already tolerated. So Monday morning identity work is brutally specific. You decide the runner's model per intent contract. You document it as part of the contract, not as tribal knowledge. You prove it with testing under different user profiles because works for me is not an identity strategy. And you establish an access review cadence for the identities that matter because agents don't stay inside the boundaries you hoped for. They stay inside the boundaries you enforced. Once you answer who does it run as, a second truth becomes obvious. Access determines what knowledge is even possible for the agent to retrieve. And that's where context architecture stops being a content project and becomes an engineering discipline. Context architecture, managed knowledge beats, attach, SharePoint, and pray. Once identity is explicit, context becomes the next point of failure. Not because models can't retrieve information. They can. The failure is that enterprises treat knowledge as an attachment, not as a managed product. And that mistake scales beautifully because the fastest way to ship an agent is to point it at SharePoint, dump in a few PDFs, add a site or two, and call it done. It feels like progress. The agent starts answering questions. People see citations. Everyone relaxes. Then the boring questions arrive. Which version of that policy did it use? Who owns that page? What changed last week? Why did the agent quote something that was replaced 3 months ago? Why does it contradict what the service desk tells users? This is the uncomfortable truth. Retrieval is only as safe as the knowledge lifecycle behind it. So context architecture starts with a redefinition. Knowledge sources aren't sources, they're dependencies, and dependencies require ownership, lifecycle, change control, and version discipline. Without those, an agent becomes a high-speed amplifier for outdated guidance. The first design rule is separation. Static knowledge is not operational data. Static knowledge is policy, procedures, FAQs, and reference material. It changes, but it changes relatively slowly. It should be curated, reviewed, and attributable. It should have a defined, effective date concept, even if it's informal. Most importantly, it should be treated as a product with an owner who cares when it's wrong. Operational data is tickets, approvals, user records, asset state, entitlements, and anything that represents current truth. You don't want that as documents. You want it through deterministic tools with schema, with validation, and with authorization boundaries. Operational data belongs in the execution and record layers, not in a pile of files the model rummages through. When teams mix these, they get an agent that confidently answers with yesterday's reality and then executes against today's systems. That gap creates incidents. The second rule is bounding. Context has to be intentionally narrow. The human impulse is to say, give it everything so it has the best chance. That's exactly backwards. Overbroad context increases ambiguity and latency, and it drives the model into probabilistic selection. Which chunk matters, which policy applies, which document is authoritative. More context doesn't mean more accuracy. It means more opportunities to be wrong with confidence. So instead of HR SharePoint, context needs to look like this policy set, these procedures, these approved templates, this set of known definitions, this glossary of terms, bounded, versioned, and attributable. That's also how you prevent cross-business unit contamination, where one group's process becomes the answer for everyone because the agent found it first. The third rule is lifecycle. If the agent can cite it, someone has to maintain it. That means when a policy changes, the knowledge artifact is updated, the old one is archived or marked clearly, and the agent is re-evaluated against the intents that depend on it, not as a nice-to-have, as a release step. If that sounds heavy, good. Enterprises already do this for code. Context is now part of the runtime, therefore it gets the same discipline. Now, a practical warning. PDF-heavy approaches are a performance and reliability tax. PDFs tend to be long, inconsistent in structure, and full of duplicated sections. Retrieval becomes slow. Chunking becomes sloppy. The model retrieves partial paragraphs that lose the conditions and exceptions that made the policy safe. And when response latency increases, you hit the exact failure modes people are seeing in real deployments: timeouts, non-responses, fallback behavior, and users resending the same request until the agent does something twice. So if the context is important enough to govern behavior, it's important enough to structure, convert key guidance into stable pages, structured content, or curated knowledge entries with clear titles and scope. Treat the source of truth as a design choice, not an accident. The last rule is attribution. The agent must be able to say where it got the answer, and the organization must be able to trace that source back to an owner and a version. Otherwise, you don't have knowledge, you have plausible text. This is how context becomes an architectural asset instead of an embarrassment in audit meetings. So the Monday move is simple. Stop thinking about knowledge as things we attach, and start thinking about it as managed context with boundaries. Curate it, version it, own it, test it, because once context is bounded and trustworthy, tool design becomes the real enforcement layer, and tools are where determinism either exists or collapses back into improvisation. Tool-first routing. Tools are contracts, not features. Once context is bounded, the next failure point is predictable. Tools. Most teams treat tools like features. Let's connect Outlook. Let's add ServiceNow. Let's give it Dataverse, as if the agent is collecting plugins like a browser. That thinking is why agents drift into chaos. In an enterprise, a tool is not a capability. It's a contract. It is an explicitly exposed pathway to change state in a system you already struggle to govern. So tool-first routing means this. You design the tool surface area before you design the conversation, because the conversation is just how users request contracts. The contracts are what actually happen. A tool contract has 4 parts: purpose, inputs, outputs, and failure modes. Purpose is not integrates with ServiceNow. Purpose is create incident with these required fields in these assignment groups under these conditions. Inputs are typed parameters, ticket category, affected service, urgency, requester identity, business unit. Outputs are not success. Outputs are record ID, state, timestamps, and any downstream workflow status. And failure modes are where adult architecture lives. Permission denied, validation error, throttling, timeout, duplicate detection, partial success, and system unavailable. If you can't name the failure modes, you can't operate the agent. You're just hoping. This is also where deterministic execution actually gets enforced. The model can reason all day. The only thing that matters is whether the action layer accepts or rejects the request based on explicit rules. That's why Power Automate, logic apps, and API-backed actions belong here. They validate inputs, they apply fixed mappings, they return structured errors, and they can be wrapped in idempotent patterns, so retries don't create duplicate side effects. An agent calling a tool is not automation. It's invoking a contract, so the allow list matters more than the prompt. Tool-first routing starts by shrinking the surface area. Enterprises love broad tools because they feel flexible. Let the agent read and write anything in Dataverse. Give it access to all SharePoint sites. Allow create, update, delete so it can help. That flexibility is just unpriced risk. The principle is simple. Prohibit create, update, and delete unless the business sponsor can explain the exact outcome metric it supports and the exact audit evidence it will produce. Read-only tools are your default. Write tools are exceptions. Delete tools are almost never defensible. And when you do allow write actions, you split them into narrow single-purpose operations. Not update ticket, instead set ticket state from new to in progress. Add work note with a required template. Assign to group from an approved list. Each one becomes governable. Now, tool selection policy. This is the part everyone handwaves with. The model will choose the right action. That's not governance, that's gambling with a nicer UI. Tool selection has to be deterministic from the organization's point of view, which means you either route based on intent, contracts, and preconditions, or you don't route at all. If two tools can satisfy the same intent, you pick one. You don't let the agent improvise between them based on wording. This is why the orchestration layer should behave like a policy router. Given intent X and verified context Y, call tool Z with payload schema S. If the context doesn't satisfy the preconditions, the router doesn't try something else. It refuses or escalates. And yes, Copilot Studio gives you multiple ways to implement this. Topics, tool definitions, agent flows, and emerging protocols like MCP for controlled tool invocation. The mechanism isn't the point. The point is that tool invocation is a governed decision, not a creative act. Now add guardrails that people pretend are optional. First, require confirmation for high-impact actions. Not "are you sure?" Say in a friendly sentence. A structured confirmation that restates the action in precise terms. What will change, where, under which identity, and what record will be written. Second, separate preparation from commit. Let the model assemble the request, validate the parameters, and present the plan. Then commit through deterministic execution only after preconditions and confirmations are satisfied. Third, log every tool call with enough detail to reconstruct reality later. If you can't answer what happened without rereading a chat transcript, you didn't log. You performed theater. Tool-first routing is how you keep the agent honest. You stop asking what can it do and start asking what contracts are we willing to expose, under which identities, with which evidence. That's how you build an agent that can act without becoming a liability. And once the tool surface is explicit, orchestration stops being a vague agent flow. It becomes a structure you can test, version, and keep small on purpose. Orchestration design. Topics, flows, and the minimal conversation surface. Once tools are contracts, orchestration is the thing that prevents those contracts from turning into a bucket of sharp objects sitting on a desk labeled AI. Orchestration is how you decide repeatedly which contract is allowed to run, in which order, with which inputs, and with what commit points. It's the difference between a governed service and a chat session that happens to touch production. In Copilot Studio terms, people will argue about mechanisms. Topics versus generative orchestration, agent flows versus Power Automate, actions versus prompts, MCP versus connectors. Mechanisms are implementation details. Orchestration is the structure you impose, so the mechanism can't drift into improvisation. Start with topics, because topics are still the cleanest way to make a path repeatable when the outcome matters. A topic is not old-school bot design. It's a deterministic route through a known decision boundary. If the intent triggers a state change, you want the predictable container, trigger, parameter collection, validation, tool invocation, confirmation, record update, and a final response that reflects the actual outcome. And the design rule is simple: structured topics for execution paths. Use freeform conversation where you can tolerate variance, clarifying questions, knowledge lookup, and triage. But don't let freeform language drive execution branching, because that's how you get the same request going down different paths depending on phrasing, context chunks, or which prompt got edited last week. So the conversation surface becomes minimal on purpose. The agent should ask only for missing parameters, not for storytelling, not for help me understand. not for open-ended dialogue that makes the user feel heard while the system collects unreliable inputs. Minimal conversation means if a parameter is required, ask for it. If it isn't required, don't. If a parameter can be derived deterministically, derive it. Don't ask. If ambiguity exists, the agent should say so explicitly and force disambiguation before it touches tools. That sounds strict because it is. Execution needs strictness. Now flows. Flows are where long-running work stops being a chat problem and becomes a systems problem, which is where it belongs. If the action takes more than a few seconds, document generation, multi-system updates, approvals, provisioning, don't trap it inside a conversational loop. Kick off a flow, return a receipt, provide a status check, end the turn. And the hidden benefit is operational. Flows can be built with idempotency patterns, correlation IDs, retries, and timeouts that chat cannot give you. If the user asks twice, the system should detect same request already in progress and return status, not run the action twice. That's not an optimization. That's how you avoid double execution incidents. So orchestration should treat long-running execution as asynchronous by default. The agent becomes the interface. The workflow becomes the engine. The system of record becomes the truth. Which leads to the next design rule. Status updates aren't politeness, they're control. If execution takes time, the agent must report state transitions. Accepted, validating, awaiting approval, executing, completed, failed, escalated. Those aren't progress messages. They are how you prevent users from resubmitting, how you preserve trust, and how you make operations debuggable. And yes, you want retries, but you want idempotent retries, not try again and hope. If the workflow can safely retry a step, it should. If it can't, it should stop and hand off with the evidence captured. Now, escalation isn't a fallback topic with a generic apology. Escalation is a designed handoff where state is preserved. If the agent can't proceed, missing entitlement, failed precondition, ambiguous input, system down, it should produce a structured package. What the user asked, what it verified, what failed, what it attempted, and what a human needs to complete the work. Then route that package into the right queue with ownership and SLA. That's how you avoid the most common operational dead end. Try again later. Try again later is how you create duplicate tickets, inconsistent records, and user workarounds. So the orchestration structure you want is almost boring. A small set of execution topics with strict parameter collection, a deterministic tool invocation policy, asynchronous flows for real work, explicit status transitions, idempotent retries, designed escalation with state, not a shrug. And here's the part that will bother people who want agents to feel magical. When orchestration is done correctly, the conversation gets smaller, not bigger. Because the goal isn't to simulate a helpful colleague. The goal is to run a controlled system through a human-friendly interface. Once you accept that, the architecture becomes obvious. And you can finally do the thing most agent programs avoid until it's too late. You can manage agents like a portfolio, not like a craft project. Governance, agent portfolio management, not one-off bot craft. Here's what happens after the first agent ships. Nothing stays the first agent. It becomes a template, a precedent, and an excuse. And if governance doesn't exist as an operating system, you don't get an agent program. You get agent sprawl. Dozens of semi-owned chat surfaces wired into production systems, each one temporary, each one carrying a little more security debt. So governance, in agent terms, isn't a committee, it's portfolio management. A portfolio means an inventory, an owner, a life cycle, and a repeatable way to decide what gets built, what gets promoted, what gets retired, and what gets blocked. And it needs a loop. A real one. Plan, implement, manage, improve, extend. Not as a slide, as an operating rhythm that survives maker turnover and leadership attention drift. Plan is where the organization forces discipline. Outcomes, scoped intents, risk tier, and the non-negotiables. Identity model, system of record, audit requirement, and refusal rules. This is also where you classify the agent. Because not every agent deserves the same controls. A discovery agent that only retrieves curated policy guidance isn't governed like an execution agent that can mutate records. If you govern them the same, you'll either suffocate harmless agents or undergovern dangerous ones. Both outcomes are common. Both are failures. Implement is where teams prove they can build within constraints. Tool allow lists, environment strategy, and release gates. This is where you prevent the most predictable architecture erosion. Building in production because it's just a small change. Agents degrade that way faster than apps because prompt edits feel harmless. They aren't. They are behavior changes. Manage is where organizations stop pretending ownership is implicit. Every agent needs an accountable owner and a technical owner. Accountable means they take the heat when the agent causes rework, risk, or reputational damage. Technical means they can actually change the thing when it drifts. If those aren't named, the agent is already orphaned. It just hasn't been discovered yet. Inventory is the other half of manage. You need a tenant-wide list. What agents exist, where they're deployed, what channels they run in, what data they touch, what tools they can invoke, and which identities they run as. Without that, you don't have governance, you have hope. Improve is where the feedback loop gets operational. Not users said it was cool. Actual signals, escalation patterns, failure modes, intervention rates, and which intents produce exceptions. And yes, this is where you do the boring work. Tighten contracts, prune knowledge, remove tools, split topics, adjust refusal paths, and fix the things that keep creating human cleanup. Extend is where scale happens without repeating the same mistakes. Standardized patterns become reusable assets, intent contract templates, tool contract patterns, environment setups, and testing baselines. This is also where you decide when to add advanced capability, new connectors, new channels, autonomous triggers, without turning the platform into an uncontrolled feature buffet. Now, the governance mechanics enterprises always underestimate: environments, DLP, and release gates. Environments aren't bureaucracy, they're blast radius control. If makers can build anywhere, they will. If they can publish anywhere, they will. That's not malice, that's entropy. So you need a clear environment strategy: development for building, test for validation, production for runtime. Promotions happen through solutions and pipelines, not through copy-paste and I changed one line of instructions. And the gating rule is simple. If the agent can act, it needs a release gate that includes testing and an owner sign-off. Then DLP. Not as a checkbox, but as a constraint on connectors, triggers, and knowledge sources. You don't allow any connector that works. You allow the ones that match the contracts. DLP is where you prevent the classic drift. Someone adds a new connector to solve a one-off problem, and suddenly the agent can exfiltrate data to a place governance doesn't monitor. And finally, the part most programs skip until the incident: change control that survives people leaving. Agents are easy to build, that's the point. It's also the problem. If the only person who understands an agent is the maker who built it at 2 a.m., it isn't an enterprise asset. It's a pending outage. So governance has to enforce 3 realities: ownership, inventory, and release discipline. Because once you operate agents as a portfolio, a second truth shows up. You can stop arguing about AI quality in abstract terms and start measuring whether the architecture is holding. And measurement is where governance becomes real or becomes theater. Metrics that matter, measuring architecture, not sentiment. If governance is portfolio management, metrics are how you prove the portfolio isn't quietly rotting. And the first thing to accept is that most agent metrics are comfort metrics. They tell you the agent is being talked to. They don't tell you the agent is doing the job you delegated. Session counts, conversation volume, thumbs up ratios. Nice to have, but they don't answer the only question that matters in an enterprise. Did the system behave predictably, under control, and with evidence? So the metric set has to measure architecture, not sentiment. It has to expose where your design is probabilistic, where it's deterministic, and where humans are doing cleanup work you didn't admit existed. Start with the most honest metric in the entire program: intervention rate. Intervention rate is how often a human overrides, redoes, or corrects what the agent produced. Not escalations as a concept. Actual interventions. User says never mind, reopens the ticket, changes fields after the agent created the record, reruns the flow manually, or asks a human to validate before they trust it. A high intervention rate means your agent is producing work-shaped output that still requires human verification. That is not automation, that is outsourced uncertainty. And the enterprise tends to fund that for months because the agent looks busy. Intervention rate is how you stop funding theater. Second, determinism score. This is the metric most people don't measure because it forces uncomfortable design changes. The definition is simple. Given the same intent and the same context, does the agent take the same action path? Not does it respond similarly, does it route to the same topic, call the same tool, validate the same preconditions, and produce the same state transition? If the action path changes based on phrasing, random retrieval chunks, or prompt drift, determinism is low. And low determinism is the root cause of operational distrust because humans can't build stable expectations around something that behaves differently every time. So the practical way to measure determinism is to maintain a fixed test set of canonical requests, 10 to 50 high-value intents, and rerun them after every change. Same user profile, same data conditions where possible, same environment. Measure whether the route and tool calls remain stable. If you can't keep the path stable, the solution isn't train users. The solution is tighter contracts and smaller tool surfaces. Third, audit completeness. Audit completeness is not we have a transcript. Transcripts are narrative. Audits require reconstructible evidence. Audit completeness asks, for every agent-initiated action, can the organization show what was requested, what identity executed it, what tool or workflow ran, what record changed, what preconditions were checked, what approval occurred, and what the outcome was? If the answer is kind of, you don't have an agent system. You have a conversational interface with side effects. This is where a system of record stops being an integration detail and becomes the core control. If you aren't writing structured entries into the system of record for agent actions, you are building an unauditable automation layer that will end exactly how you think it will end. Now add operational KPIs, but tie them to strict definitions. Resolution rate only matters if resolved means the workflow reached a defined terminal state. Deflection rate only matters if deflection means no human had to intervene later. Mean time to resolution only matters if you measure it from request to verified state change, not from chat start to chat end. Otherwise, you can improve the metric by ending sessions faster while pushing work downstream. The last metric that separates mature programs from pilot programs is refusal quality. If refusal is a feature, it should be measurable. How often the agent refuses, why it refuses, and whether refusal routes users into a clean escalation path with preserved state. A refusal that creates a usable ticket with context is a control. A refusal that tells the user to try again later is just a delayed failure. So the metric set becomes a dashboard of architectural truth. Intervention rate, determinism score, audit completeness, operational KPIs with real definitions, and refusal quality. And once you track those, two things happen. First, you stop arguing about whether the agent is good. You start seeing where the system is uncontrolled. Second, you realize metrics without testing discipline are just forensic reports after trust is already damaged. So the next mandate is evidence test like software because you're shipping a system, not a personality. Testing discipline. From try it out to evidence. Once you start measuring determinism and intervention, you run into a problem that can't be solved with optimism. You can't manage what you can't reproduce. And most Copilot agent programs are built on the least reproducible testing method in enterprise IT. Someone trying it out in a chat pane, getting a decent answer once, and shipping. That's not testing, that's a vibe check. Agents don't need more encouragement, they need evidence. So the testing discipline has to look like software discipline, adapted for a probabilistic component. Not because the platform is broken, because the platform is doing exactly what probabilistic systems do, they vary. Your job is to bound that variance until it becomes operationally acceptable. The first shift is simple. Move testing left. Early, repeatable, and tied to the intents you actually care about. Before anything goes near production, you define a core scenario set, 10 to 50 scenarios that represent the real outcomes you're delegating. Not edge cases, not fun prompts, not clever demos, the boring high-frequency paths that will generate tickets, approvals, changes, and audit questions. And you test them every time you change anything that can alter behavior. Instructions, topic triggers, tool definitions, knowledge sources, connector auth, models, even environment policies, because those are all behavior changes. Some are just disguised as configuration. Copilot Studio gives you multiple ways to do this, and the point isn't which feature is best. The point is you stop relying on memory and start relying on repeatable runs. Use the built-in evaluation capability when it fits. Single-turn checks for quality, groundedness, and completeness. It's useful for quickly catching regressions in generative answers, and it can generate test sets based on your agent metadata, knowledge sources, or past chats. That's fine for breadth, but don't confuse that with end-to-end proof. Single-turn evaluation won't tell you whether a multi-turn execution path collects parameters correctly, validates preconditions, calls the right tool, and writes to the system of record. It won't show you idempotency failures. It won't show you what happens when a connector throws an HTTP error halfway through a workflow. So for execution scenarios, you need multi-turn automated testing. That's where bulk testing approaches like the Copilot Studio Kit become the adult option. You run test conversations that include the messy user request, the clarification turns, the confirmation step, the tool invocation, the error path, and the escalation path. And you run them at scale because non-determinism hides in volume. The goal isn't to prove it works. The goal is to discover where it fails before users do. Now add the most ignored part of agent testing, identity profiles. An agent that works under a maker account proves nothing. You test with designated user profiles that reflect real entitlements, standard employee, privileged operator, regional user, contractor, service desk analyst. Same intent, different identity, different access graph. That's not a corner case, that's the system. Because many agent failures are just authorization reality finally becoming visible. The test discipline has to surface that deliberately, not by surprise in a team's channel. Then you treat tests as architecture artifacts. They are versioned, they are owned, they live with the solution, they run in pipelines, and they gate releases. If you can't describe your release gate in one sentence, we won't promote this agent unless core scenarios pass under these identities and tool calls produce these records. You don't have a release process. You have hope with deployment permissions. And yes, you need regression after every change. Agents drift from small edits, knowledge updates, connector changes, model updates, capacity limits. Those aren't hypothetical, they're routine platform reality. So the discipline is same test set, same thresholds, rerun continuously. Finally, testing has to include failure path design, not just success path validation. Force the tool to fail. Remove permissions, break the dependency, exceed the token limit with oversized inputs. Trigger throttling, watch what the agent does. If it masks the failure with language, that's a defect. If it escalates with state preserved and evidence attached, that's architecture. This is what enterprise grade actually means. Not fewer failures, but failures that are predictable, explainable, and containable. Once you have that evidence loop, you stop debating whether the agent is ready, And that's when operations becomes the next inevitability. Drift doesn't stop because you test it once. It just becomes visible sooner. Agent ops, drift, incidents, and platform reality. Now take that testing discipline and assume it worked. You shipped. Core scenarios pass. The agent behaves. Everyone celebrates. Then the real system starts operating, the one made of people, policies, connectors, models, and monthly platform updates. This is where agent ops stops being optional and becomes the only thing between successful pilot and quiet abandonment. Agent ops is just the operational truth of agents. These systems drift, and drift creates incidents. And drift does not require malice or incompetence. It only requires time. Drift shows up in 3 places. First, you change the agent. Instructions, triggers, prompts, knowledge, tools. That's a behavior change wearing a friendly UI. Second, dependencies changed. Connectors, schemas, catalogs, choice values, conditional access, DLP, tokens, secrets, licensing, capacity. Third, the platform moved. Models update, retrieval indexing shifts, throttling changes, preview features sunset. The agent didn't get weird yet. Your runtime changed. So the mandate is simple. Treat agents like services. Services have runbooks, they have telemetry, they have incident reviews, they have backlogs, they have owners who get paged when reality disagrees with the demo. Start with reliability patterns, because most agent incidents are boring in the same way. Timeouts, partial completions, duplicate execution, silent tool failures, inconsistent routing, users resubmitting the same request because the agent went quiet. So you design for that. Retries exist, but only where the operation is idempotent. If a create ticket action can run twice and create 2 incidents, you don't retry. You add a correlation ID and a deduplication check in the execution layer. Then retry becomes resume, not repeat. Timeouts exist, so every long-running action needs explicit time budgets and user-visible state transitions, accepted, queued, awaiting approval, executing, completed. If it fails, the agent returns a receipt with a record ID or escalation artifact, not a paragraph. Fallbacks exist, but fallbacks must be engineered. If the model can't confidently route, it should ask a disambiguation question or escalate with context. A fallback that produces plausible text is not resilience, it's fraud with better grammar. And human-in-the-loop checkpoints aren't a concession, they're a control point. High-impact changes require a human approval gate, even if the agent did everything else. That's how you keep autonomy from turning into liability. Now, observability. This is where most agent programs collapse because they rely on chat transcripts like they're logs. They're not. Transcripts are narrative, not telemetry. You need instrumentation for which intent fired, which topic ran, which tools were invoked, which identity executed them, how long each step took, what errors returned, how often users abandoned, and how often escalation happened. Tool call telemetry matters more than the agent said something. And you need to capture latency because latency creates user behavior. When agents take too long, users resubmit. Resubmission creates duplicates. Duplicates create rework. Rework destroys trust. This is not user training. This is system behavior. Then you need an operational posture. Weekly review, not quarterly post-mortems. Look for drift signals, rising intervention rate, rising fallback rate, increased unrecognized utterances, increased tool call failures, rising latency, more escalations in a specific intent. Those are leading indicators. If you wait for the incident, you've already lost adoption. When an incident does happen, the review has to be brutally specific, not the model hallucinated. That's not a root cause. The root cause is always architectural. Missing precondition checks, ambiguous routing, overbroad tool surface, unowned knowledge, identity mismatch, or inadequate logging. And every incident produces a backlog item that hardens the system. Tighter contracts, better validation, narrower tools, improved escalation artifacts, additional tests, and clearer runbooks. That's the real promise of agent ops. Not that incidents disappear, that incidents become containable, explainable, and less frequent over time. Because the uncomfortable truth is that platforms will keep moving, the tenant will keep changing, your organization will keep accumulating entropy. The question is whether your agent program treats that as AI being AI or whether you run it like production. If you choose production, drift becomes a managed cost. If you choose vibes, drift becomes your entire story. Whereas in the executive playbook, the 5 decisions leadership must force. At this point, the pattern should be obvious. Agent failure isn't a tooling problem. It's a leadership problem disguised as a maker problem, because agents sit at the intersection of accountability and automation. And if leadership doesn't force a few hard decisions up front, the system will make those decisions for you, accidentally, inconsistently, and usually during an incident review. So here are the 5 decisions leadership has to force. Not suggest, not encourage, force. Decision 1. what the agent owns end-to-end and what stays human. This is the boundary between assistance and delegation. If the agent owns an outcome, it owns the workflow path, the tool calls, and the evidence. If a human owns it, the agent can guide, summarize, and prepare, but it does not commit. Leadership has to pick because ambiguity here creates blame later. And the fastest way to kill adoption is to ship an agent that sometimes acts and sometimes doesn't, with no reliable rule behind it. Decision 2. The identity model and the least privilege boundary. Leadership has to decide whether execution runs as the user or as a service identity per intent. Then enforce least privilege as a design constraint, not a security aspiration. This is also where leaders stop tolerating temporary access. Agents will operationalize whatever access debt you've accumulated. If the business wants action-capable agents, the business funds identity hygiene, access reviews, app permission discipline, and a clear runners pattern that survives staff turnover. Decision 3. The system of record and the audit requirement. An agent that acts without writing to a system of record is not an enterprise system. It's an opinionated chat session with side effects. Leadership has to name the record authority per workflow, ServiceNow, Dynamics, a line of business system, and make it non-negotiable that agent actions produce reconstructible evidence, request, identity, preconditions, approvals, tool invocation, outcome. If that evidence doesn't exist, the agent isn't allowed to execute. Simple rule, massive impact. Decision 4. Release gates, testing thresholds, and rollback expectations. If leadership wants deterministic ROI, leadership forces deterministic release discipline. That means pre-production environments, versioned changes, test sets that cover core intents under real identity profiles, and a pass threshold that blocks promotion. It also means rollback is designed, not improvised. When the platform shifts under you, and it will, you need a way to revert behavior quickly without a late-night prompt edit in production. Decision 5. Success metrics tied to outcomes, not demo quality. Leadership has to kill vanity metrics early. Session volume is not success. Positive reactions are not success. Success is an operational delta that survives outside the agent team. Reduced escalations with strict definitions, reduced rework, faster approvals with preserved compliance, measurable cycle time reduction, improved throughput, and intervention rates trending down over time. And leaders have to assign metric ownership. If nobody owns the metric, the agent doesn't have a goal. It has a launch date. When these 5 decisions are explicit, the rest becomes execution. Contracts, tools, context, orchestration, governance, measurement, and operations. And when they're not explicit, what you get is predictable too. Chat-first agents with broad permissions, unclear boundaries, and an AI is unpredictable narrative that conveniently avoids the actual root cause. This is what thought leadership should really do in this space. Stop arguing about whether agents are ready and start forcing architectural honesty, because the platform will keep improving. Models will keep changing. Features will keep shipping. That's not your constraint. Your constraint is whether you can turn probabilistic reasoning into deterministic operations. And that only happens when leadership decides what gets enforced. Conclusion. Agents don't fail because they're dumb. They fail because you ask them to act without a control plane. And architecture is what turns probabilistic reasoning into governed execution. If this helped, leave a review so fewer teams keep funding chat-shaped risk. Connect with Mirko Peters on LinkedIn and tell him what you're building, and send the next failure pattern you're seeing so it becomes the next episode.